Okay, let's pick up where we left off. So we talked about discrete versus continuous functions, talked about linear functions, and now I want to make sure we address the other thing that we touched on this unit, which is exponential functions. Exponential functions. Okay, so what is an exponential function? These are functions that increase or decrease by multiplying by a common ratio R. So when you think of, you should already be thinking about common ratios of geometric sequences. Okay. So I want to start the same way I did with the linear functions, where we're going to look at start by looking at the equations. So in unit 1, we got a lot of practice writing geometric explicit equations. And those look like this, where we said a sub n is equal to a sub 1 times the common ratio r to the power of n minus 1. So in other words, a sub n is equal to the initial value times the common ratio to the power of n minus 1, or a sub n is equal to a sub 0 times r to the n. Okay, so that was unit 1. In unit 2, we're going to think of these as exponential functions. But they're going to look almost identical. So this time they're going to look like this. F of x is equal to f of 1 times r to the power of x minus 1, or f of x is equal to f of 0 times r to the power of x. Now, notice these look very similar. The structure is almost identical, where I have here my initial value. Okay, my initial value. This is my initial value. And my common ratio R. So these are the same structure in slightly different notation. Okay, take a second and finish copying this down into your notes. Pause if needed. Okay, we're going to do another example problem, just like we did for the linear section. So here we go. We're going to do an exponential example problem. So here's going to be the problem. An animal shelter has 3 unicorns. Each day, when the manager arrives, in the morning, there are 2 times as many unicorns as the day before. Okay. What's the important information here? Well, I'm starting with 3 unicorns. This is my initial value. And this is an exponential or geometric situation because I'm increasing by 2 times. I'm going to have to multiply. And 2 is going to be my common ratio. All right, again, we're going to represent this, start with a table, make an equation, and draw a graph. So how do I make a table for this situation? Okay. Well, I have x and f of x. X is days, and f of x is number of unicorns. Okay, my initial value, I start with 3 unicorns. On the next day, I'm going to multiply by 2. I'll have 6 unicorns. Another day goes by, I multiply by 2 again and get 12. Multiply by 2 again, get 24. So that's the pattern here, right? I have a common ratio of 2, meaning each day, my amount of unicorns is going to double. Right? This is my common ratio. Well, how do I write this in an equation? I have this formula. Well, what's f of 0? F of 0 is 3. That's my initial value. That's my initial value of 3. And I have a common ratio of 2. So that's it. That's all I had to do to write an equation. There's my common ratio of 2. And here's my initial value of 3. Lastly, we're going to draw a graph. So I'm going to draw some axes. On the y-axis is going to be days, right? On the x-axis is going to be unicorns. The number of unicorns. So let's see. Let's go up by 6s, maybe? I think that'll work. 6, 12. And in days, we'll just go up by 1s. Okay, again, grab a different color here. Okay, my initial value is 3. So at day 0, I have 3 unicorns. That's my initial value. That's where it's represented on the graph. Right there. Initial value of 3. After 1 day, I have 6 unicorns. After 2 days, I have 12 unicorns. After 3 days, I'm up here at 24. You can see like the space between the dots is increasing. And I have a curve. Okay. Well, what if I just had it started with a graph and I wanted to figure out what the common ratio was? Well, you might notice from here to here, I doubled, went from 3 to 6. Again, from here to here, I went from 6 to 12, I doubled. From 12 to 24, I doubled. And remember, you can always use this little formula that said we had with unit 1, I said to find the common ratio, you can divide a sub 2 by a sub 1. Or you could say it's the same thing to say I can divide f of 2 divided by f of 1 to get the common ratio. So like if I took 24 and I divided by 12, well, sure enough, I will get 2. Okay. All right, pause for a moment so students can get this all copied into their notes. Okay, I know it's been a long time of taking notes. I have one last thing I want to say, which is, what if I want to write a linear equation from a graph? Okay, I'm gonna draw a graph. So draw some axes. So you might have a problem like this come up in a packet where you have a couple of points given. And a line. It's already going through the 2 points. So this is going to be the point 0, 2. And this is the point 3, 4. So I want to figure out, how do I write an equation from this? Well, recall, I can use y equals mx plus b. I just need to find b, which is the y-intercept, and m, which is the slope. So I need to find the y-intercept b and the slope m. Okay, well, what's my y-intercept? The y-intercept is just the place where the graph crosses the y-axis. So the y-intercept is the place the graph crosses the y-axis. And in our case, it's at 2. So for us, we have b is equal to 2. That is the place at y equals 2 that the graph crosses the x-axis, the y-axis. Okay, the other thing we need to do is find the slope. Well, remember, slope is equal to the rise over the run. So we need to determine the rise over the run. Rise is the change in the y values, how far up and down I go. And the run is the change in the x values, how far left and right I go. Okay, so I usually just jump count. So how far up am I going between these points? I'm going up 1, 2, 2. So my rise is 2. How far do I have to go to the right? I'm going 1, 2, 3. right? Because I'm going from a x value of 0 to an x value of 3. So I move to the right 3. So I have a slope of 2/3. My rise of my run is 2/3. So how does all this stuff translate to an equation? Well, again, I just need to plug in my pieces. I have y equals mx plus b. Well, my m, I just discovered is 2/3. And my b is 2. So that's it. All I had to do. Took a already graphed line and figured out what the equation is. Okay, that is all I have. You can pause for a moment on this page if students need to finish taking notes. And then we will work on that packet from last class. I hope you all have a lovely Thanksgiving break. I'm going to miss you all, and I look forward to seeing you when we get back. Okay, bye-bye.